Have you ever looked at an apple and went like, wow, this is a miracle? It doesn't normally occur to us, but trees are actually living things, and most living things need to eat. So today we are using chemistry to learn from how plants have breakfast, lunch, but probably not dinner. Plants make their food using photosynthesis. This needs carbon dioxide and water to operate. After a series of reactions, the meal, which is sugar, is prepared and oxygen is seen as waste and then removed via leaf holes, aka stomata. Let's try to imagine how this would work if this was purely a chemical reaction. Since the right side of the equation has an even number of oxygen atoms, the water molecule must double up. There should also be 6 carbon atoms on both sides, so there must be 6 carbon dioxide molecules. There are also 12 hydrogen atoms on the right side, so water molecules should also be a group of 6. This gives 18 oxygen atoms on the left side, so there are 6 O2 molecules. Done. It all works out. Except living things don't work that way. Life is complicated. What really happens is that the water is split using sunlight, becoming protons, electrons, and oxygen atoms. The oxygen atoms form O2 and is removed as waste molecules. The carbon dioxide and the remaining particles of water generates glucose through complicated processes. Yeah, life is hard, but it goes on. Let's look at the basic reaction. If you really are concerned about how all this really works, watch organic chemistry vids instead. We aren't going to look at the inner workings of enzymes here. For now, let's look at carbon, hydrogen, and oxygen's bonding habits. Carbon naturally has 6 electrons and 4 of them are exposed to the outside. Those can be used to make 4 covalent bonds, as not a lot of atoms would want 4 electrons at once. This can be shown in methane. Oxygen has 6 exposed electrons, and though they're all open to bonding, oxygen normally just uses 2 to get an octet. You can even see this in plain old water. Hydrogen, however, is mainly used to fill gaps in the bonding. Oxygen wanted just use 2 hydrogen atoms. Not enough bond space for a CO double bond? Use hydrogen atoms on oxygen. Hydrogen only bonds with 1 atom at a time. Now, back to the reaction. The carbon dioxide is split first. Carbon separates and leaves O2 behind. This becomes a waste product. The carbon atom would then join water to form COH2. 1 carbon, however, forms COH and H. Glucose forms when COH2 bonds with each other. It is H, COH2, 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 COH. Unfortunately, this reaction can't happen in real life. Carbon dioxide and water are happy with their current state. Life just found a way. Hey, maybe I'll even do a video on organic chemistry. That's the end of this video. I hope you learned something from this video, like the bonding habits.